Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Hey, we're here live at Bill L. Williams Elementary School, home of the Pioneers, and we are here to... Okay, we're here at Bill L. Williams Elementary School, home of the Pioneers, on a nice balmy day here in Bakersfield. But we're glad we're inside because we get to do a little math, and the students here have told me that they're working on fractions here. And so what better way that I know of to work on fractions than to do some factor trees. And so, crew, pens ready, please. Off we go. We talked about this just a minute ago. Can you do me a favor, regardless of what the person next to you has written down, okay? Can you take the number 30 and give me two numbers that multiply together to be 30? We're going to start there. Write it down. That's a good job. Good job. Let's see what we got. Two numbers that multiply to be 30. And again, you could have a different answer than the person next to you, so don't worry about that part. If you get one of those combinations of numbers, see if you can maybe find another one. I see multiple answers here. Nice job. Frankie's working on another one. Amy, you got a bunch of them, man. Nice work. I like it. So this is the kind of problem that in math doesn't always just have one answer. And that's important to realize that you don't always have to have one answer for every problem. As long as you can explain what's going on to someone around you, it'll be okay. All right, so let's see if we can come up with a whole list of them here. I saw somebody started off with a 1. If you started off with a 1, what would the other factor be? 30, okay. How about a 2? Can we do a 2? 2 times? 15, that's a big one. Maybe you missed it, maybe you got it.
5 times 6?
5 times 6, sure. We can do 5 times 6.
3 times 10?
3 times 10. Did we miss any? Is there another one? Anybody use any fractions?
Don't think so.
Anybody use any decimals? Okay, well, we'll stick with whole numbers today then. Okay, so wonderful job here. Now, there's lots of different ways to break down 30, but what we really want to know is, what are the smallest pieces? What are the smallest pieces of 30, if you broke it on down? So I told you about a factor tree a little while ago. Let's see if you can do the same thing here for 30. Let me give you an example. If you did 2 times 15, you can't break down 2 anymore. We're all done there. You could break down 15 into smaller pieces. Go ahead and do that. Try it with 5 times 6. Try it with 3 times 10. And tell me, please, what are the smallest numbers you can use to multiply to get 30? And please don't use a 1. Let's see what you got. Break down 30 to the smallest pieces. Oh, I like the factor trees. Good. Diego's got it going on. 15 is going to be broken down. Josh has got it. Very nice. What else? There you go. Good start. You can even start with 5 times 6 if you want to. Oh, wonderful job, Melanie. I like it. You started with 6 times 5. Tell me a little bit about this one. Is 5 all the way broken down? I think it is. That's why you stopped. I like what you did there. 5 is all the way broken down because all you can do is 1 times 5. But how'd you break down 6?
3 times 2.
3 times 2. That's it. So at the very end, what are the 3 numbers you would multiply to be 30? Come up with all those 3 numbers at the very end. Now, wait to hear. Good place to start, Amy. I like it. So far, so good. We're definitely thinking. I can hear the motors turning. What about over here with this crew? Good. So you started with 2 times 15. 5's all done. Is 3 all finished? Annabelle?
Yes.
3's all done. Is 2 all done?
Yes.
2's all done. So there's our numbers, right? No matter where you started, hopefully at the very end of this problem, you got a 2 and a 3 and a 5, right? Because if you do 15, it's 3 times 5. Okay? Even if you started a different way, let's say you had a 30 and you started with 3 times 10. That doesn't look like that, but if you break down 10, 2 times 5, there's your 3 numbers. All right, we're gonna do one more of those, and I promise you, this really does have to do with fractions, okay? It doesn't look like it yet, but it really does. Let's do one more, are you ready? Okay, let's start at the top of our factor tree with a number like, oh, how about 12? Break down 12 into a couple pieces. Doesn't matter how you start. Don't use a 1, please. Break down 12 and then break it down into the smallest possible pieces you can. And I will show you why this is useful. How's this crew doing over here? Katie, what do you got? Oh, you're still working on 30. Boy, really good job on 30 there. Thomas, you break down 12 there? Looking good. Alice got lots of different ways to do 12. Anybody getting the smallest possible pieces here? Looking good. Break down 12. I like it. Start with 2 and 6, just exactly like you did there. That's a wonderful way to do it. Start with the 2 and 6. Annabelle got the 2 and the 6, and then you broke down the 6 from there. Nice job. One more check over here. Ah, that's it. Jaden, look at this, 12. 6 and 5. Oh, make that a 2, but I like how you broke down that 6. Nice work. And over here, Frankie, oh, really well done. 2 and 6, and you broke down the 6, 2. 2 and 3, that's what we're looking for. So the beginning doesn't matter. You can have a different answer for other people than other people around you. Let's say you decided to do 4 times 3. Didn't see a lot of people with that one, but you could do it. Because at the end, here are your 3 numbers, 2 and 2 and 3. So, great start to fractions. If you're still curious about how this works with fractions, that's good, because we're going to show you when we come back. We're going to do a little bit more factor trees. When we come back, we're going to do some reducing fractions with prime factorization, something very exciting to look forward to. We're back here live at Bill L. Williams Elementary, home of the Pioneers, ready to do some work with fractions, and no one's quite sure how that's going to happen yet. But we've been working really hard on factor trees, and we've come up with a wonderful list, and people have already seen this. We have a list of numbers that we've broken down into 2 factors. Those are the ones on the left-hand side. So we broke down 4 and 6 and 10 and 15 and 25. Nice job, crew. Then we broke down some numbers that have a couple more factors. So over here on the right-hand side, we have numbers that have 3 factors, 12 and 20 and 30 and 18. And now is the time when we get to use these. So we're going to use these for reducing fractions. Are you ready? Let's do one that we've already done to make sure you're in good practice about what's going on here. Can you take a fraction like 4 over 10? We want to reduce this fraction and make it smaller. Can you write that down on your board, please? 4 over 10. And right next to that, write down the factors of 4 and the factors of 10. I even have them up here on the board for you, so you don't have to go back and make a new factor tree. Factors of 4 and factors of 10. What are the factors of 4? How do you break down 4?
2 times 2.
2 times 2, well done. What about 10?
5 times 2.
2 times 5, or 5 times 2, that's right. Some people like to put the 5 first, some people like to put the 2 first. And you just got those right from here. So if you haven't already, cross off the number that is the same on the top and the bottom. Israel got it? Melanie got it? Once you cross off the number that's the same, you are left with a reduced fraction. So we're going to cross off the 2's. What are you left with?
2 times 5.
2 over 5. That's it. So we have reduced this fraction. All right, so there's a simple one. We'll do one more simple one. It's pretty easy, right? Okay, we'll do another simple one, and then we'll move on to some ones that are maybe a little bit more difficult. Here we go. How about if we do 10 over 25? What the heck? What are we going to do with that? 10 over 25. We broke down 10 and we broke down 25. 10 goes on the top. 25 goes on the bottom. Let's see what you got. Danielle, how do you break down 10?
5 times
5 times 2. That's a good way to do it. 5 times 2. That's it. Michael, how'd you break down 25? Did you do that one yet? No. What two numbers multiply to be 25? Annabelle got it. What two numbers multiply to be 25, Annabelle?
5 times 5.
5 times 5, good. So you have a 5 on the top and the bottom. Nora, did you get it? What are you crossing out? You crossed off the 5. So what's the final answer on this one?
2 figs.
Oh, what the heck? The same thing? 2 times 5, 5 times 5. Look at that, it is the same thing. So another one of those problems where the result at the end, right, happens to be the same, but we started with a different problem. Okay, let's get a little more fancy here. Next one I want you to try is, let's see, how about if we do 6 over 20? And this is gonna be an interesting problem for you. I think you're gonna like it. 6 over 20. Let's see what we can do here. How do you break down 6? This crew back here is on it. Diego's got it. 3 times 2. What a great way to do it. I like what you've done there. And break down 20. If you forget all the way at the end of 20, it's on the board there for you. You're welcome to use it. Ah, we got a couple different answers here, and it's good to be able to check with the people around you to see what's going on. Okay, help me out. How do you break down 6? 2 times 3, that's it. That's from our list here. Now the 20 that I have on the board is 2 times 2 times 5, and you can use that one if you want to. Some people put 2 times 10, which is okay as well, right? But I like the one that says 2 times 2 times 5. And again, they're right here on the board. Okay, what can we cross off? The 2, that's it. So what are we left with? On the top, we have a 3. What do we do with the stuff that's left over? Multiply it back together because it has a times sign in between, right? So now we have 3 over 10. What a super interesting problem. Even those ones that you think might be tough can be done really well using this method. I like this way to do reducing fractions. We're going to do some more, even more complicated, super fun problems when we come back. Hey, thanks for returning for segment 3 of Reducing Fractions here at Bill L. Williams Elementary School. We are ready to make sure we can reduce fractions like champs using the factors of each number we're looking at. So, pens ready. Here we go. The first one we're going to try to reduce is 15 over 20. And use the numbers that I have given you up here, the ones that you have previously broken down. You've already broken down 15. You've already broken down 20. So use the numbers that you already have on the board here, so you don't have to do all your work again a second time. Looking good. Looking good. I see some good work already. 3 times 5 on top. Oh, I like that, Danielle. That's it. You're going to make some smaller numbers. Annabelle has 2 times 2 times 5 on the bottom as well. So I see some really good things. Here on the top, the unanimous decision seems to be 3 times 5. Good start. What about 20? Did anyone use 2 times 10?
No.
You could, right? But you have to go even further. Did anyone use 4 times 5? You could, but you have to go even further, right? We would really like to use 2 times 2 times 5. Let's do it. 2 times 2 times 5. What crosses off?
5.
The 5's cross off. What do you have left? 3 over 4. That's it. If you have 2 numbers left over, you got to multiply them back together. Here we go. Round 2. Are you ready?
Yes.
That's what I thought. Ready? 18 over 30. This is going to be a good one. Both of these numbers have 3 factors. Okay? Both these numbers have 3 factors. 18 over 30. Make sure you get all 3 factors, and don't use any numbers that can still be broken down. I like what I see there. Frankie's got it too. Caleb's coming. Diego's got it. Break them down as far as you possibly can. Remember, you don't have to do the work yourself. The broken down numbers are right up here on the board. You can use those ones. Whoa, excellent breaking down. Now ready? Cross off the numbers that are the same, top and bottom. So it looks to me like we have a consensus here. 2 times 3 times 3. Is that 18? Is that what you got? What about 30? Somebody give me 30. 2 times 3 times 5. Good. We have all kinds of things that can cross off. This is one of those really neat problems where you can cross off more than one number. Are you allowed to do that? Oh, yeah. 2's go away. What else?
3.
3's go away. What do you got left?
3
3/5. That's it. 3 over 5. Really well done. Okay, now we're going to challenge you. Here it comes. Dun, dun, dun. 18 over 20. Both of those numbers also have 3 factors. You can do it. Break it on down, Alex. 18 over 20. You can pull those numbers right from our list here. In fact, both of them are here on the right-hand side. Danielle, what's 18?
2 times 3 times 3.
Wonderful job. What else? Annabelle, what's 20?
20 is 2 times 2 times 5.
Nice job. Now, it's not quite like the last one because you won't be able to cross off more than one number. So, gentlemen, are you ready? What number can you cross off?
2.
The 2. Let's do it. Ready? There goes the 2. But we have all kinds of numbers left over. Is that okay? Yeah, it's totally okay. No big deal. So on the top, we have a couple 3's left over. What do you got there? 9. 3 times 3 is 9. What about on the bottom?
10.
Nice job. So 18 over 20 reduces to 9 over 10. Okay, now here comes the most challenging one of the day. Not hard, but it's got a unique result. Are you ready? Here it comes. 4 over 12. Seems pretty simple, and I think it's definitely one that you can do. But we got to make sure we do a little bit of thinking with this one. The top number only has 2 factors, and the bottom number has 3 factors. And there will be a unique result that I think that you might be intrigued by this one. I think you'll like this one. So take a second. If you get stuck, check with someone next to you. Maybe they have an idea for you. Yeah. Wonderful job. Oh, I'm already so impressed.
Wait
All kinds of stuff going on here. Diego's got an answer. Josh is getting there. Michael's got it. Wow, look at this.
Wait.
Okay, so let's find out this unique result. Give me 4. What's 4? 2 times 2. Is there anything else you want to put in there? Because I saw a couple other people with some other number there. What number can I put there and not change the 4? 1. Oh, somebody got it. 2 times 2 times 1, you'll see why that's important in a minute. What about 12? 2 times 2 times 3. So this 1 here is going to be important because 2's are going to be crossed out. Bang, bang. And if you didn't have the 1 there, you might forget. 1 over 3. Here's the last rule I'll leave you with. If everything else goes away, you forget to put the 1 there. If everything else goes away, Israel, nice job. There's always a 1 left because we're doing multiplication. Always a 1 left. And it's always a good time to reduce fractions. We are so grateful for the opportunity to be here today, to be able to do some reducing of fractions with these pioneers